In this video, we're going to look at the cumulative binomial distribution function. Now, in a previous video on the binomial distribution, we ended with this question here. We were asked to find the probability that x was less than or equal to 1 given the binomial distribution, or x following a binomial distribution with 12 trials and a probability of 1/6. And the way we worked that out was x being less than or equal to 1, we worked out the probability that x was equal to 0 and the probability that x was equal to 1, and we just added those together. Now, if this question was slightly different, if this said the probability that x was less than or equal to 6 or x was less than or equal to 8, what we wouldn't want to have to do is work out the probability that x is 0, then the probability that x is 1, then that x is 2, then that x is 3, and so on. It would take us a very long time. So instead, we're going to use something called the cumulative binomial distribution function. So a cumulative probability function for a random variable x gives us the sum of all the individual probabilities up to and including the given value of x. If we think about that word cumulative, we've seen that in cumulative frequency. What that means is it's all of the probabilities so far added onto the current one. So often we see this written as the probability that x is less than or equal to our given value x. So the value for the random variable is less than or equal to our given value of x. Now it's important that we recognize this less than or equal to part of our function. And we can find probabilities for the cumulative binomial distribution using binomial distribution tables. They are given in the formula sheet in exams. There are some in the back of the Pearson Edexcel textbook as well. So we're going to use those, and also I'm going to demonstrate use of that function on a calculator as well. So here's our example. We're told Emily plays a game in which the probability of winning is 0.15. She plays the game 20 times, and we're being asked to find the probability that she wins 6 times or fewer, more than 3 times, and then at least 5 times. So our first step, as it always is on our binomial distribution questions, is to write out our distribution. So x follows a binomial distribution where the number of trials is 20 and the probability of success is 0.15. Now, to find the probability that she wins 6 times or fewer, we can use the probability distribution tables, the binomial distribution tables. So in those tables, there are different sections. I've just copied the section where n equals 20, but there are different sections, different sets of tables for some different values of n. So I know there's some for n is 8 or when n is 10 and so on. We're going to look for the section where n is 20. So when n is 20, we've got our probability here. Now, in our distribution, we said the probability was 0.15. So I'm interested in this column here, and we want our probability to be less than or equal to 6, because our question says 6 times or fewer. So that is the probability that x is less than or equal to 6. Now, our binomial distribution tables give us the probability that x is less than or equal to our value. So that's perfect for this question here. I can simply go down to finding where x is 6, and that is going to be 0.9781. So 0.9781, and that's our answer there to 4 decimal places. The second question, we're being asked for the probability that she wins more than 3 times. Now, the probability that x is greater than 3 to be able to use our tables, we need this to be in the form less than or equal to. So if I think about it, the probability that x is greater than 3, that is equal to 1 minus the probability that x is less than or equal to 3, because either x is greater than 3 or it's less than or equal to 3. They are two exhaustive events, essentially. Either it's greater than 3 or it's less than or equal to. And this value comes from our tables. So x being less than or equal to 3, I've got this 0.6477. So I can say that that is 1 minus 0.6477, which is equal to 0.3523. So that is the probability that Emily wins more than 3 times. Finally, the probability that she wins at least 5 times. Now, at least means it can be 5 or it can be more. So that is the probability that x is greater than or equal to 5. Now, if x is greater than or equal to 5, that must be the same as 1 minus the probability that x is less than 5, because either it's greater than 5 or it's equal to 5 or it's less than 5. They are the only possibilities. Since greater than or equal to are covered here, I can only put less than there. Now, our binomial distribution was a discrete distribution. Our number of successes could only take a whole number of values, 0, 1, 2, 3, and so on. So if we're considering a situation where x is less than 5, being less than 5 must mean it is less than or equal to 4. And we need to use the value 4 because we need the equal to part for our tables. So 1, that is equal to 1 minus the probability that x is less than or equal to 4. If it is less than 5, it must be less than or equal to 4. Then I can use the value in my tables for 4, which was 0.8298. So that is 1 minus 0.8298. And that is going to give us 0.1702. And that there is the probability of her winning at least 5 times. Now, we can do that using the stats tables. We've got the stats tables there. There are also methods that provide the same information, in fact more information, using our calculator. So I've got a couple of the A-level calculators. First of all, the CASIO FX991EX. I've also got the CW to show you as well. So in that calculator there, if I go into the menu and then find distribution mode, that is 7, and then I need to press down to get to binomial CD, and then 1 for binomial CD. Because I've only got a single variable, I am going to press 2 for variable, and then that gives us this little menu here. Now, if I just look at question A, I can set that for this question A, my x value was equal to 6. N was my number of trials, so N was equal to 20. And my probability is 0.15, when I press equals and then equals again, that is going to give us that 0.9781. We've got it rounded to 4 places here. They've got it written to a few more places on our calculator. Now, why our calculator is really valuable on this, our tables only give us specific probabilities going up in 0.05s. Our calculator would be able to do this for a range of probabilities. If a question asked us for a probability of 0.18, for example, we wouldn't be able to do that with our tables. We can do it on the calculator though. So having these calculators is incredibly important. Before we finish with this video, I just want to show you the same thing on the newer CASIO calculator. So this is the FX991CW. So on this calculator, we can press our home button. So if I press home, I can then go to distribution mode and then binomial CD, binomial cumulative distribution is there. And then I can choose variable. And then we've got that same menu there. So on that first question again, X was equal to 6. I've got that N was 20 and that the probability is 0.15. I can then go down and hit execute. And when I do that, I get that same 0.9781. And again, the value of these calculators is that we can find a range of probabilities rather than the rather limited set of probabilities that we get in the stats tables. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.